Alright, so looking at this graph, it's also on your manual. So this is a lab setting we're going to use to calculate the height of center of gravity. But how come this kind of setting can give us the information we want? Let's start from a free body diagram. And before really drawing a free body diagram, we need to know the most important thing today. That's the moment. So the moment is kind of the force applied to rotate an object. And it's not just only the force. The distance to the axis of rotation also matters. So longer the distance, the higher the moment is. So actually, that distance is called moment arm. So moment equals to force times moment arm. So larger the force is, the larger the moment is. So if you apply more force, you can rotate the object easily. And if the distance from the force to the axis of rotation is longer, then also you'll be able to generate more moment and rotate the object easily. So remember these two key concepts: force and the distance from the force to axis rotation. And the distance is called moment arm. So this is the free body diagram, and obviously this is a human lying on a board, and here is fixed, it's the axis of rotation. And we have a weight scale here. You can measure the force between the board and the weight scale here. So we can think about it as a force applied to the board. So the first steps to draw a free body diagram is to list all the forces. So think about what are all the forces you can think about in this free body diagram. The first thing will be the weight of the human, right, the subject. And the second weight, WB, will be the weight of the board here. And the third force will be the force applied from the weight scale to the board. That is Fs. So that's all the forces we have in this free body diagram. But we're thinking about moment today, right? So the next component is the moment arm. So the second step is to find the moment arm for each forces. So from the human body, the weight is here, and the distance from the force to axis of rotation is here, the c, and c is actually the height of our center of gravity. So c is the key component we want to calculate today. Alright, how about the mass of the board? Mass of the board, you can think about is from the middle of the board, right? So here L is the moment arm for the board. And this force is at the end of the board, so its moment arm is 2L. Alright, so we've found all the moment arms in this free body diagram for all the forces. The third step, think about, is the board rotating? It's not, right? It's in equilibrium state. So now the total moment will become 0. So how come the total moment becomes 0, but we got 3 forces here? That means all the clockwise moment should equal to counterclockwise moment. Does that make sense? Okay, so next step is to identify all the clockwise moment and all the counterclockwise moment. So let's take a look at each force. For the human body, the body weight, is it rotating the board clockwisely or counterclockwisely? It's rotating clockwisely, right? So it's a clockwise moment. And how about the weight of the board? It's also a clockwise moment, right? And how about the force at the end of the board? It's on this direction, which rotates the board counterclockwise. So it's a counterclockwise moment. So the concept is clockwise moment equals to counterclockwise moment. And the clockwise moment will be this one, the weight of the subject times c, right? Force times moment arm, W times c. And also the other force from the weight of the board is also a clockwise moment. So it's WB times L, half of the length of the board. How about counterclockwise moment? is applied by this force at the end, right? It's generated by the force here. So it's Fs times 2L. And because we know clockwise will equals to counterclockwise, so we can write the equation like this. W times C plus WB times L here equals to counterclockwise moment, Fs times 2L. And we do a little bit high school math, want to move, because we want to calculate C, right? That's the focus today. We want to know the height of the center of gravity. So we want to move this guy to the right side of the equal sign. So that becomes this one, Fs times 2L minus WB times L. And how to solve C right now? We divide everything by L, the body weight. So you got C equals to this whole thing. And that's the equation you want to use to calculate your height of center of gravity. So once you got the Fs, the scale reading, and you got 2L, the length of the board. You got the weight of the board and half of the length of the board and your body weight. Put everything inside the equation and you'll be able to get the height of your center of gravity. So that's from the free body diagram to the equation we're going to use today. So according to the free body diagram, here are the numbers you need. So we need the mass of the board, the length of the board, and also your body mass and scale readings. So we'll talk about these numbers in next video.